Welcome to this year's FIRA World Cup video submission for Team Galaxis. First of all, we want to give you an insight about how we develop our car. This is our team room. It contains many utilities and tools as well as workstations. In front of the room we have a small test track which we use for quick testing of new features. In addition, we have a larger mobile test track with more advanced traffic scenarios. We use it for final tuning and testing of the car every year in the weeks before a competition. The current team consists of 11 members led by Parad and me. While Parad mainly focuses on perception and has put great effort into our new traffic sign detection, Jan and I have been at work on a new environmental model. Patrick joined the team 1.5 years ago and has worked on various topics including stop line detection and obstacle evasion, while Pratyush has specialized in homography and simulation. Yanis, KH Safkat and Galib are currently working on a complete redesign of our car to improve stability while driving quickly around corners. Ömer, who joined half a year ago, has been actively engaged in working on planning and simulation. Both Marco and Fabian joined the team recently, and while Marco has taken it upon himself to improve our workflow and tooling, Fabian works at improving our onboarding and line detection. Our car consists of 2 computing units. The first is a self-developed breakout board which acts as a bridge between the hardware components and the main computing unit. The main computing unit is an NVIDIA AGX Xavier. It perceives the environment based on sensor and camera data, performs inference tasks, and finally calculates the reference speed and steering angles. When necessary, control of the car can be seized at any time via the remote control and can also be returned to the car. Next, we present our car in a racing and an obstacle driving scenario. Both disciplines are one-take recordings and the whole track can be seen in the lower right. To achieve good lap times, the car has a model predictive controller. It is highly tunable and improves the lane keeping performance compared to simpler approaches. The MPC adjusts the speed based on track conditions. To update the trajectory reference at a higher rate and thus allowing for higher speeds, the environmental model decouples the trajectory update from our slower lane detection updates. In obstacle driving, our car has to avoid a number of obstacles on track. To give you more of an insight into the perception and planning of our car, we show the debug output of our trajectory planning on the upper right and right below the lane detection in action. These outputs degrade the performance of the car and were consequently disabled in the former discipline to achieve maximum speed. For our small team, we pursue an agile development strategy with weekly meetings. Tracking of new or ongoing feature development is done in GitLab issues and for important features in our project plan. To start our development process, a feature request is created. It is a GitLab issue that describes the feature and its requirements. In this case, we decided to implement a detector for the traffic signs from the FIRA World Cup. In the next weekly meeting, an assignee is determined who will be responsible for the feature. The assigned person researches the literature to gain an overview over the topic and determines possible implementations. For our traffic sign detector, the assignee found 3 possibilities: a template matching based approach, a deep learning based approach, and a hybrid of depth clustering and template matching. We discussed the findings in a weekly meeting and determined the requirements to our hardware and our software for the solution. The tasks are derived and distributed to team members. For the traffic sign detector, we decided to implement the hybrid approach, as this seems a good compromise between robustness and runtime. A prototype based on the approach is implemented and evaluated for its performance. The prototype is then integrated into our codebase. In our example, this would mean writing code to access RGB camera images and depth camera images and sending information about the detected signs to other relevant software components. The implementation is tested in simulation and then on the real car. For the traffic sign detector, the detection of signs using clustering on depth images is tested here. Finally, the new software component is documented using Doxygen and READMEs.